Okay, done.
Thank you, Dustin, for those great insights into BIM and sustainability. Hello, everyone. We are thrilled to be here virtually with this specially recorded session, which takes you into the circular economy where waste doesn't exist, and BIM is the first step in that journey. Dustin and I are also really delighted to be here today alongside our expert and co-speaker, Rabia Sharef, who will introduce herself later. We're really excited to share our insights and enthusiasm for BIM and the circular economy. So regardless of your perspectives in design, construction, facilities management, or digital, we hope that you will be inspired by this presentation. A little bit about me, briefly. I've spent the last decade working in BIM and Autodesk partner consultancies in both the USA and the UK. In 2016, I discovered the circular economy in a program that was intriguing and appropriate for our time. It was called the Enterprise, Innovation, and Circular Economy. This was a pivotal moment for how CE can improve the built environment and the 40% resources used by this sector. Currently, in my role at BSI, I work with the built environment sector across the Americas, connecting our extensive resources, subject matter experts, domain teams with communities, clients, and partners who share common goals such as climate change, sustainability, and resilience. My work expands to the circular economy, which you will see is becoming more important to Mexico and the USA. Now I welcome Rabia Sharef, who will introduce her next.
Thank you, Auguste. Just a few words to introduce myself. I worked as an architect for 15 years, and I have to admit that I never really considered the end of life of buildings when I was designing them. To change that, I went back to school to learn new ways of working, and I discovered technologies like BIM and how we can link the design with the asset end of life. I finally moved my career to academia. Now I am a researcher at Lancaster University, focusing on digitalization, material passport, and trying to make the built environment greener. I am deeply committed to making my research practical, and I am also involved in the standardization activities at the European level. Now, without any delay, let's delve into this exciting webinar. The floor is yours, Auguste.
Thank you, Rabia. So we have only 30 minutes, so I will speed through our agenda. So why is the circular economy important? We're going to look at the new legislative acts and the impetus for the circular economy in Mexico and the US. Then we'll introduce circularity by talking about the key influences and contributors, the movement, and the inspiration and principles that lead to it. We'll address some key factors on CE governing principles for materials and how crucial design considerations become. We'll introduce you to the CE butterfly with examples, and we'll cover the linear economy and how we got here. We'll take a quick look at circular construction and BIM as a building block. Then we'll highlight very briefly some circular economy building business models, enablers, and building blocks. And finally, we'll bring the circular economy, nature's inspiration, and the built environment together in two case studies. The first is a quick look at a US brownfield project and ecological restoration using circular principles. Next, we'll look at Rabia Sharef's case study highlighting the approach of reusing existing materials, 3D models, and building with a collaborative and respectful approach. We'll end up with some recommendations and insights to raise awareness. And then lastly, we'll hand over to Dustin for final comments. All right, so why should we care about the circular economy? There are a couple of reasons. In February 2023, the plenary of Mexico's City Congress approved circular economy law of Mexico City. It includes the promotion of circular economy to eliminate waste and regenerate natural systems, recovering products to promote economic growth and creation of green jobs. Further, there's help for market differentiation for Mexican firms who are promoted through a circularity label after meeting incentives and sustainability criteria. So why is this also important to us? Because the US and Mexico are partners, and because we have undergone similar legislation. We have 3 acts. One is the Inflation Reduction Act, the CHIPS Act, and the Infrastructure Jobs Act. These are worth over $1 trillion through key investments and tax incentives. Similar to Mexico, we're looking at reducing pressure on resources like EV batteries and clean energy tech, recycling of materials like steel and concrete, and extending life cycles for products so that we can reduce the greenhouse gas emissions and create a net zero pathway. And of course, there's the green new jobs and industries. But perhaps the key takeaway is that circularity is written into these acts. So it legitimizes CE, whereas we don't believe that happened in the States or in Mexico before. And funding is available for innovation that will be part of a wider sector requirement in the supply chain and will fan out into the built environment. And now that we've covered the 2 main reasons for circularity, let's get into what it is. There are major influences shaping the circular economy. One is the book Cradle to Cradle, Remaking the Way We Make Things by Michael Braungart and Bill McDonough, published in 2002. It introduced the concept that materials should have a planned future, becoming an input for another process in a continuous sustainable cycle. Another architect and economist, Walter Stahl, champions the concept of product service systems. The focus is providing services, not product sales. For example, cooling as a service, charging the building operator on a pay-as-you-use basis. In this way, the manufacturer retains ownership of the system, enabling the reintroduction of old components back into their own supply chain. They never lose custody of their product or, in fact, their brand and customers. It's a really powerful concept. Janine Benyus is the author of Biomimicry, Innovation Inspired by Nature. So we'll look at what she means from a forest perspective that could be mimicked by a smart city. Finally, Ellen MacArthur Foundation. Founded in 2010 by Ellen MacArthur, the EMF has significantly accelerated the transition to a circular economy. There are many videos and thought leadership articles and information on the internet, and I highly recommend that you take a look at that. In the rest of our discussion, these concepts shape new thinking for today's challenges and opportunities. So what is the circular economy? It's an economy driven by design based on 3 principles, which is to eliminate waste and pollution by design, circulate products and materials at their highest value, and regenerate nature. At its very heart, it's an industrial system that's regenerative and replaces old concepts on end of life by using superior design of materials and products, systems and business models. But more importantly, as an industrial system, it actually has monetary value, a lot of value. In a 2022 report called The Evolution Towards a circular economy, Goldman Sachs estimates the circular economy to help add $4.5 trillion in additional economic output by 2030 and 25 trillion by 2050. With these types of numbers, it's not just a maybe or nice to have, but signifies a real business proposition. So we've established the why of a circular economy, and here is an easy way to visualize it in the butterfly diagram, which governs how materials are separated by type and the treatment throughout their life cycle. In the biological cycle on the left, the smaller, tighter loops represent innovative byproducts, such as textiles from orange peel or animal feed from mushrooms, before moving to much larger, broader applications. On the right, we have the technical cycle. This is where your smartphones, laptops, sheetrock, steel, glass, etc., benefit from modularity, disassembly, adaptability, repairability, etc. In both cycles, both loops contain more of the material's original value, including embodied carbon. So this leads us to an important question. How do manufacturers reclaim materials from products years after they've been installed in the built environment? If you look at the companies on the right of the slide, Armstrong, Shaw, and Topkit, they all have take-back systems for reusing materials. Old ceiling tiles become new ceiling tiles. Old carpets become inputs for new carpets. These materials are diverted from landfills and reduce new raw extraction of materials. And this really ties in with the goals of the legislative acts in the US and Mexico, as well as the initiatives created by the Sustainable Development Goals. Next, we look at the perfect ecosystem, illustrating a connected, closed-loop systems approach that was mentioned by Janine Benyus and inspired by nature. This is biomimicry and the forest. CE influences call for designing our homes, communities, and cities in a similar fashion to a forest. It's a perfectly designed ecosystem for carbon sinks, vegetation, animals, pollinators, all your water systems, and mycorrhizal networks, which preserve the soil and create and help regeneration from below. There's no waste in nature, and everything equals food or input for something else. It's a true cradle-to-cradle closed-loop system. And nature also creates perfect products, such as the humble banana. The entire product is usable by all consumer markets, as well as in business-to-business settings for nutraceuticals. And in fact, in some tropical countries, the entire tree is consumed, including the trunk, which is another vegetable. And in a landfill situation, bananas facilitate decomposing of adjacent organics. So you might ask why it matters how the forest, banana, or material segregation occurs. Why do we care? We care because design has long used nature as inspiration. However, somewhere along the line, there's a disconnect between design nature and how we design products for our world and use. In this slide, all these items are very likely recyclable according to the manufacturer, but hardly any are recycled or reused. In a building, a collection of highly valuable materials and products like steel, concrete, woods, glass, pipe, etc. Some have a designed-in plan for reuse, recovery, remanufacture. However, much of it will be discarded because there isn't a way for these materials to get back into the supply chain or secondary materials market. However, We think this is a matter of time before QR codes, RFID, IoT sensors are used to tag, meta tag, and identify the manufacturer, life stage. Reverse logistics and take back information will become visible via digital twins and similar technologies. And we suggest it will happen because of new laws, environmental regulations, and extended producer responsibility. So why do we have this situation? We call this the linear economy. This is an economy that is a take, make, waste economy where goods always move in one direction. From raw extraction, manufacturer use to waste. As we know, sometimes that use is only 1 minute, like the plastic bottle. The Industrial Revolution brought many benefits. For the first time, goods were able to be mass-produced, raw materials and energy seemed to be infinite, and industrial countries have become societies of abundance, with soaring populations, and many millions have been pulled out of poverty. So where there are middle classes that can afford to live without disease or hunger, this has a legacy footprint of process, machinery, logistics communities that rely on the linear economy. And the next slide, borrowed from Rabia, shows the comparison of both economies, and perhaps we can understand why it's difficult to get out of this linear economy. Here they are illustrated together. But for now, we know that there is funding available through the legislative acts, and there's a impetus for it, for change. And we think that it will arrive with new project requirements. Further, design software is getting more sophisticated in terms of built-in sustainability for building performance, material choices, etc. There are many opportunities to make a difference in individual ways that fit your organization. For instance, we can look at a circular construction approach. On the top in yellow is the linear economy, and below is the circular economy. We'll look very briefly at BIM as an entry point and enabler to more sophisticated new technologies, circular economy, and other business models. And Rabia will walk you through the business case of why BIM and 3D modeling makes so much sense. BIM is the foundation for sustainability, circularity, and is really an entry point to many more technologies. Because a lot of what you need to do in sustainability and the circular economy is based on data. If you can't find it, then you can't reuse it. You can't take it to the next critical operation. So you need effective tracking, material passports, life cycle management, manufacturer locations, future ESG considerations for scope 1, 2, and 3, and also extended producer responsibility regulations, which are coming. Yes, this is what BIM does for you. It will reduce your design, bid, build, and operate silos, and if done right, remove those silos. So within a common data environment, all stakeholders have continuous updated real-time access to information from any place, anywhere, throughout the project, and even beyond project teams. I encourage that you take a look at some of the videos and the reading materials in the links here. I will leave this here for reading at another time, because we're out of time to get to my case study. But briefly, these are all enablers to get to the data, because data is the backbone of the circular economy. So here is a case study of the Ford Rouge Center which is the Ford car maker site and facility. It's a master planning and revitalization by Bill McDonough of Cradle to Cradle book. At the heart of the new system lies a 10.5-acre living roof, the world's largest green roof installation at the time, and is an example of the circular economy principles regenerate nature. It also follows forest biomimicry and closed-loop ecosystems, reclaim and reuse of wood, steel, glass in a continuous cycle. Rainwater is harvested and reused, and natural ventilation is used throughout. All the materials used follow a cradle-to-cradle principle, not cradle-to-grave. So at the time of install, there's awareness of where that material, once it reaches its useful life or gets degraded, where is it going in the next process? And it's something that is not landfill or incineration. Again, there's a link here that is very useful to take a look at it. And now I turn you over to Rabia Sharef and her very interesting case study featuring 3D to 8D and is a result of many years of research.
Thank you, August, for sharing insights and on this fascinating topic. So just to sum up what August just said, what is the problem for the construction sector? The sector is responsible for an enormous volume of waste and consumes a huge amount of natural resources. But the undeniable truth is that we have only one planet with limited resources, and the demand is continuously increasing. Another reality is that the construction sector is lagging behind compared to other sectors. It is still undigitalized, fragmented, and clinging to conservative practices. So we are facing a lack of efficiency and a sustainable growth dilemma. How can we address these challenges? First, we need to digitalize our sector. This means adopting technologies like BIM to streamline processes and improve efficiency. Second, we must change our design methods. We need to start by designing buildings with their end of life in mind. We need to think about how these buildings can be adapted and repurposed over time to ensure flexibility and adaptability. We also need to think about what will happen to the material when a building can no longer be used. This is where design for disassembly or design for deconstruction comes in, because these approaches make possible the reuse of materials. We also need to move from our current linear economy to a circular economy, as it was explained by August. In a nutshell, we can say that the circular economy considers waste as a resource and buildings as material banks. So changing our working method, what does it mean? We need to move away from the silo working practices and instead work collaboratively by using BIM technology. I won't go back over BIM as you have covered it during this event, but I just want to recap some information about what is the 3D model and the difference with the 3D BIM model. It's the data that we put on it. Mm-hmm. We add graphical and non-graphical data. And just to name a few of benefits that we can have in mind if we want to go with BIM. Of course, we have this improvement in terms of visualization and understanding. It helps for communication and coordination between the different stakeholders. And also, BIM can be used for the maintenance and operation of buildings. But all this data collected throughout the asset life cycle has the potential to support the management of the end-of-life activities. and beyond, because the data could be used by material recovery facilities and also by material banks or material platforms. So there are several BIM dimensions. We have seen the 3D BIM model, but we also have the 4D, 5D, 6D, and 7D. In 2019, a European study, revealed a certain consensus between academics and practitioners around the 4D and the 5D, related to planning for the 4D and cost activities for the 5D. However, for dimension beyond 5D, the study also revealed a lack of clarity among academics and practitioners. 6D for some people means sustainability, and for others, it means management, the facility management activities. And the similar confusion is about with 7D. So there is a real need for standardization in this area, because there is no common consensus about what is 6D and 7D. The study also revealed that the building's end-of-life activities were associated with none of the existing dimensions. More recently, in 2022, a study filled the gap and proposed the 8th dimension for managing the end-of-life activities. This study explored how BIM can enhance end-of-life activities by explaining the different BIM models. And the 8D could be used for the creation of the deconstruction information model. That's the model that will contain all the information related to the deconstruction. It could help for the audit to assess the recovery and reuse potential of buildings. And it can also facilitate the matching between supply and demand for recovered materials. And as we can simulate the construction of a building by using 3D BIM model with 4D, we can also simulate the deconstruction scenarios and decide to go for the more sustainable strategy. So if we want to use BIM for the asset life cycle, we need to think about the data and how this data could be maintained and updated to be with a very good quality. And that's where Material Passport comes in. So now, when all these materials are recovered, how can we facilitate their recirculation, keep them in a closed loop, and prevent them from becoming waste? According to Thomas Rowe, waste is a material without an identity. So with Material Passport, we can provide this identity to every single material to keep them in circulation and put in this Material Passport all the data related to the material. It will help to maintain the value of the materials, and it will also help to stop relying on recycling, which generally doesn't keep the material at its highest value. If you want to know more about Material Passport, you can scan these QR codes that are in the presentation. So to solve the problem, we also need to move away from our current linear economy. Many studies highlighted the importance of refurbishing and reusing existing buildings if we want to meet our environmental goals. In fact, between 85 to 90% of today's buildings are expected to still be in use by 2050. So it is crucial to consider our buildings as material banks and extend their service life as much as possible. So now let's move to a practical example of this approach. The project that I am going to present is the Beaucastel Winery, very famous for producing some of the finest wines in France. The original building dates back to the 17th century, and the domain has been extended several times. An architectural competition was organized with 1,200 applicants from 32 countries. It's just to highlight the global interest of this project and the prestige. Studio Mumbai from India and Studio Mediterranee from France won this competition. This case study was designed by a team that considered their approach to be based on common sense and respect for the environment. The philosophy of this project centers on the concept of building together. This means developing a respectful and collaborative relationship with materials. They were inspired by Tim Ingold's making, who considers materials as active collaborators and not just resources. The project was not developed within the BIM environment as we know it, but the project team worked collaboratively and used the 3D model to support their willingness to adapt the design to the material and not the other way around. As architects, the team ensured that the design flowed naturally with the surrounding. They also integrated the design seamlessly into the environment rather than trying to impose it. This approach perfectly aligned with what Auguste presented, the idea of mimicking nature where no waste does exist. Let me explain the approach and construction process for the Boucastel project. For this project, the first thing they did, they assess and understand the site and existing buildings. They identified what could be preserved, renovated, and reused. They usually consider having two types of materials. The natural site materials, the one we have under our feet, earth with clay, pebbles, gravels. The design team worked collaboratively with masons, structural engineers, researchers, and the client. And they looked at how they can use this material for the construction. The second type of materials, they usually name it the human introduced site materials, and they analyzed the different existing buildings and categorized them in three periods. The first period was quite well constructed, and they used materials that were easy to reuse, like stone, pebbles, wood. So for this period, they kept everything and they repaired the building. For the second period, they deconstructed 40% of the structure and they recycled metals and concrete. Unfortunately and interestingly, the more recent period has proven less easy to reuse for two main reasons. The first reason is that the buildings were mainly made with composite materials that are difficult to separate and reuse. And the second reason, they often contain plastics. So this project could have been designed in BIM and use material passport to help for the audit and the deconstruction. In particular, for example, the use of material passport could facilitate the management and tracking of recovered materials. It will be easier in the future to reuse the material because they have an identity and the data related to their life. Although this building is not certified as circular, it was designed and constructed with closed-loop approach because it reused 80% of the existing materials. They used several innovative techniques. On the right, you have the site-rammed concrete made of excavated soil with cement. On the bottom left picture, you can see the rammed earth wall. When the soil has clay, cement is not necessary to manufacture the rammed earth. They use just earth and water. And in the center, you can see the pneumatic rammer that was used for both techniques. Even old timber beams have been recovered and upcycled to make furniture. This project is remarkable, a remarkable example of resilience. It demonstrates that it is possible to keep existing materials in a closed loop and limit the extraction of new resources. In this case, it was 20%. So based on this study, we have identified several challenges at different scales. Because we are running out of time, sorry, we just invite you to have a look to this list later. Next slide, please. Now, just a few recommendations and insight to raise awareness. I will pick just a few from the list. So we need to support the industry by providing guidance, standards, and incentives. Digitalization, we should use it meaningfully to avoid the rebound effect. And we must change the way we think and design our buildings and components. We need to have a long-term thinking and be aware of the long-term consequences of our actions. And we should remember that sometimes a low-tech approach could be the best option. If you are interested to know more about this project and about the information that I provided, you can have a look to the list of reference that we will provide you. Thank you for your attention, and I will give the floor to August.
Thank you, Rabia, for the fascinating look into how BIM has transitioned to today's capabilities. And also, thank you for your focused research to raise awareness and to support the sector for practical applications in the digitalization and the circular economy. So, have we sparked your curiosity? We hope so. Let me recap our discussion so far. We've introduced the circular economy and contrasted it with the linear economy. And then we've invited you to explore BIM with a look at 3D through to 8D. Then we're making the case that circularity is here. Your government and mine, ours, want us to do things differently because current processes aren't working for mankind or the planet. We have the power to design out waste before and not after it exists. And lastly, talk to us about moving your firms forward with BIM or circular economy, as we have done for many others in the world. Did you know that BSI wrote the first ever standard for BIM and also for the circular economy? So we're pioneers in many far-reaching initiatives. Thank you all for attending. And now Rabia and I hand you over to Dustin. If there are any questions, Dustin will bring it together next. And also this deck will include an appendix of useful links. Please feel free to email us as well.